Welcome to Calculus Review. I'm Philemon Viennas.
I'm Josh Thompson.
Where you gotta be mentally strong
and physically strong.
Okay, so our first topic in the Calculus Review is infinite series, and then our subtopic under infinite series is geometric series.
And before we start talking about infinite series, we must know what converging means and what diverging means. So converging, that means when a function goes to infinity, there is a sum. Now, an example of converging would be 1/2 plus 1/4 plus 1/8 plus 1/16 ... and that converges to 1. Now diverging, that means as a function goes to infinity that it does not have a sum. And an example of this would be just 1 minus 1 plus 1 minus 1 plus 1. And that doesn't have a sum.
So the subtopic under the infinite series topic is geometric series. Now, geometric series can converge or can diverge. A geometric series converges to a over 1 minus r, where r is less than 1. Now, in this formula, a is the first term in the series, and r is whatever the exponent is, whatever the constant is raised to a power. So, example, 2 to the second. 2 would be the r in this series. Now, a geometric series can diverge also, and it can diverge if r is greater than 1. So the series converges when the absolute value of r is less than 1, and it diverges when the absolute value of r is greater than 1. And the geometric series has an interval of convergence where x has to be between 1 and -1 where it converges. That is the interval of convergence.
So the basic geometric series that you must know before we do anything else is f of x equals 1 over 1 minus x. And x has to be less than 1. Now f of x is going to equal 1 plus x squared plus x to the third, x to the nth. Now we can use this to build other geometric series, which we'll do here in a moment.
Okay, so our first example of how to use what Josh just explained, the basic geometric series 1 over 1 minus x, is y equals 1 over 1 plus x. Now, 1 over 1 plus x also equals 1 over 1 minus negative x. So, for what Josh explained, this series, or the 1 over 1 minus x, which is 1 plus x squared plus x to the third, x to the nth, in that series, to find the first 4 terms and the nth term, you replace every x with a negative x, and the series alternates. So it will be 1 minus x plus x squared minus x to the third plus x to the fourth, -1 to the n, because the series alternates, x to the n. Now, this series converges, and it is written as the series goes to infinity, when n equals 0, the series converges to -1 to the n, x to the n. Now, using the same series that Josh explained previously, you can take derivatives and antiderivatives of series to find more series. For example, if you are given a natural log and you are asked to find the series, so y equals ln 1 plus x. Now, to find this, you must know the derivative of the natural log of 1 plus x. And the derivative of the natural log of 1 plus x is 1 over 1 plus x. So, okay, so we just did the 1 over 1 plus x series. So to find the natural log to find this series right here, you must take the derivative, you must take the antiderivative of this series, because the derivative equals that, so that means the antiderivative of this series equals that. Okay, so, let me erase this. So, the antiderivative from 0 to x for 1 over 1 plus t dt. Now, I just replaced x with t, and you'll see why in a minute. But so we already know this series is 1 minus x plus x squared minus x to the third. The antiderivative of this, actually, these are all supposed to be t's. So the antiderivative of this from 0 to x is the antiderivative of 1, which is t, antiderivative of negative t, which is 1/2 t squared, antiderivative of t squared is 1/3 t cubed, antiderivative of t cubed is 1/4 t to the 4th. Now, this series, the nth term in this series is -1 to the n, t to the n. So the antiderivative of the nth term would be -1 to the -1 to the n, t to the n plus 1 all over n plus 1. That is the nth term when you differentiate. Now, all this is going to be evaluated from 0 to x. So we're going back to x's, and that would be, you put 0 in all of these, the answer is 0, and when you put x in it, and all of these, including the nth term, well, including the nth term, the series comes out to be x minus 1/2 x squared plus 1/3 x cubed minus 1/4 x to the 4 and the nth term is just -1 to the n. You replace the t with an x to the n plus 1 all over n plus 1. Now you can use, as you can see, you always have to start off with the 1 minus x, which Josh explained earlier. When you're given, just to summarize, when you're given a different function that looks like 1 over 1 minus x, for example, 1 over 1 plus x, 1 over 1 plus x squared, all you do is you create something that looks like the 1 over 1 minus x, and you replace whatever the x term is in the series with the r term, and you get your series.
How do you do the integral of that one?
Yeah, you just anti-differentiate. You know what I'm thinking? For like our next topic, I'm thinking about doing like basic series like e to the x, sine of x. Do you hear it?
Yeah,
Yeah, we gotta go, bro. Building off the series that we just discussed, our first one that we're going to go that you must know is e to the x. Now, e to the x is a very special series that you must know, you just must know it. And this series goes 1 plus x squared over 2 factorial plus x on the AP Calc exam. The next one that you must need to know is sine x. Now sine x equals x, it alternates, so it's x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial. Now this series alternates, which means that it has a -1 to the n, so -1 to the n, x to the 2 to the n over x plus 2 x plus 2 factorial. Excuse my sloppy handwriting. It's not every day that you do this. Okay, now the other one that you need to know is cosine of x. Now cosine of x equals 1 minus x squared x. So for example, either the negative x would replace all these x's with wherever there's an x with a minus x. For e to the x minus 1 would just subtract 1 from this whole series. So this one would go away. To find the series of, let's say, e to the negative x minus 1, you would just replace all the x's with minus x and subtract 1 from the whole series. Cosine and sine would be the same thing because the future series. Once again, sine x alternates. Starts off with x minus x cubed over 3 factorial plus x to the 5th over 5 factorial plus x to the 7th over 7 factorial. Cosine of x, I know it's hard to read, is 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial. Cosine is always negative 1 to the n, x to the 2n over 2n factorial. Sine x, the nth term is always negative 1 to the n, x plus 2 to the n, all over x plus 2. Excuse me. Yes, x plus 2 factorial. Alright, and that is your calculus in the car. Oh!
One messed up, so I kicked him out.
I figured it out. Yeah. Alright, so this is actually what it's supposed to look like. It was kind of hard writing earlier, but for sine I messed up. It's actually x to the 2n plus 1 all over 2n plus 1 factorial. I said something completely different, and I am deeply sorry for leading you down the wrong path. So here's exactly what it looks like, and you can take a minute to get this down and learn it and study it, because you need to know this.
Welcome to Illegal Calculus. We're going to be talking about Taylor polynomials here. Now all a Taylor polynomial is just another way to find a sum, kind of like Euler's method. So the basic Taylor polynomial, P1, is going to be f at a plus f prime at a times x minus a all over 1 factorial, but really that's just 1, plus f double prime at a times x minus a to the second all over 2 factorial. And I'm going to move down here. It would be plus f triple prime at a times x minus a to the third all over 3 factorial. And then the pattern kind of continues, and it would just be f to the 4th. I guess we can just write that like that. My bad. Times x minus a all over 4 factorial, and I forgot that would be to the 4th. And that's Taylor polynomials.
Okay, so an example of when you're trying to find the Taylor polynomial is if you are given a function, let's say y equals ln x. Now, if the question says find the second Taylor polynomial, meaning you go to the second derivative. So T2, I'll just put a T2 over here. So you're going to go to the second derivative for the Taylor polynomial of f at a plus f prime at a x minus a all over and plus f double prime at a x minus a squared all over 2 factorial. Now Josh and the last one said P1, but it's actually what he was explaining was just the general series. When like P1, T1, T2, those are just specifying the derivative that you're supposed to get. So to find the second derivative, to find the second Taylor polynomial for ln x, you need, first of all, you need to be given a point to start with. So let's say you start at 1, 0. You need to find the second derivative. So the second derivative, you need to find the first and second derivative for ln x. So first derivative is 1 over x. Second derivative is negative 1 over x squared. And what you do is you would put in 1. You would put in 1 into both of these equations. Figure out the first and second derivative. 0 would be your f at a. Your f prime at a would be 1. X minus a is just you keep x there, so it would be x minus a, which is of course 1. You would do plus, you put 1 in here, which is negative 1 x minus 1 squared all over 2 factorial. So it's going to look like 0 plus f prime at a, once again, is 1, x minus 1 plus f double prime at a. F double prime is negative 1 times x minus 1 squared all over 2 factorial. And you can use this to estimate a value. For example, if you were trying to find ln at 1.1, you're trying to approximate this value. All you would do was put 1.1 into for x, and you would come out to be 0.095. So this is approximate. So you can approximate a value using the second Taylor polynomial. Find 1.1 for ln. And once again, Taylor polynomials, this is just to estimate a value, to estimate an area, and so forth.
Today we're going to be learning about the ratio test.
The ratio test.
Now the ratio test can be a little bit difficult when you first get to learn it. Some of it might be hard to understand reading it. We just got to stick with us and get through this with us together. So let's go ahead and jump right in to the ratio test.
Okay, so what my friend Josh just wrote down was the ratio test, which is when the limit as n goes to infinity for a to the n plus 1 over a to the n has to be less than 1. This is how you find the interval of convergence. This is an interval convergence test. Okay, so like I just said, the ratio test is a to the n plus 1 over a to the n has to be less than 1 as the limit as n goes to infinity. So right here, this is a to the n. This is the original series function right here. So you replace every n with an n plus 1 right here. So n up here is replaced with n plus 1, the n right here is replaced with n plus 1, n down here is replaced with n plus 1. And then you divide it by the original series. Now, no teacher would make you divide all of that by that. So you just multiply and flip. So you put the denominator in the numerator, in the denominator, and you get that. Now to finish this up, to find the limit, to find the integral convergence, you have to finish solving this, which is you look at this. So there's one more n up top than there is in the bottom for this -1. So -1's up top. For this, there is one more 2x up top than there is in the bottom, because this is that's n plus 1. This is n plus 2, that's n plus 1, so there's one more 2x up top, so that's times 2x. Now for these, you cannot simplify, they have to go over each other. So this would be times 2n over 2n plus 2. So to finish this up, you cannot simplify these n's, but you can separate the x's and you can separate the n's. So this would be -2x times the limit as n goes to infinity for 2n over 2n plus 2. Now the limit as n goes to infinity for 2n over 2n plus 2 equals 1. Because these are basically the same. So this is, and the interval of convergence for the ratio test is always between -1 and 1. So this is actually, I messed up. There's actually absolute value around this right here. Absolute value is with the x's. So this is 2x has to be between -1 and 1, which means -1/2 has to be between, so the interval of convergence has to be between -1/2 and 1/2. And that is the ratio test.
So the last essential thing you have to know to be successful on the series portion of the AP Calculus exam is the p-series. Now p-series is when the exponent is in the denominator and p is the exponent. So it'd be 1 over n raised to p. Now when p is greater than 1, the series converges, okay? And then when p is less than 1, the series diverges. And now we'll do some examples.
Okay, so an example using the p-series test to see if a series converges or diverges is this one right here. We have, as the series goes to infinity for 12 over n cubed, we are trying to determine if the series diverges or converges. What you can do is you can bring 12 out front, since it is a constant. 1 over n to the 3, that looks like p-series to me. 3 is greater than 1, so it converges.
Damn, it feels good to be a gangster.